AI is basically running our world now. It's making decisions about our jobs, our loans, even our freedom. But what happens if there's a huge hidden blind spot in these powerful systems? That's what we're digging into today: algorithmic bias. We're going to pull back the curtain on this massive issue. And just so you know, what we're covering here is a quick look, a brief overview based on a much deeper, more comprehensive tutorial from Virtualization Options LLC.
All right, I'm going to start with just a number, 34.7%. Any guesses what that could be? I'll give you a hint. It points to a huge problem in the world of AI. Just let that number sink in for a second.
Okay, here's the reveal. That number, 34.7%, that is the error rate for some major facial recognition systems when they try to identify dark-skinned women. Now get this, the error rate for light-skinned men, it's less than 1%. I mean, that is just a staggering difference. This jaw-dropping discovery comes from a study called Gender Shades by researcher Joy Bulam-Winnie, and it's the perfect and honestly pretty scary example of how AI can completely fail entire groups of people.
And look, this isn't just a facial recognition problem. It's so much bigger. The AI expert Kathy O'Neill really nailed it when she said AI can amplify existing inequalities if left unchecked. Just think about that for a moment. It's like taking all the biases that already exist in our society and putting them on steroids, automating them at a massive scale. So the big question is, how on earth does this even happen? So to figure that out, we've got to get into the anatomy of the problem. We need to break down what algorithmic bias is and, where it's coming from. Only then can we even start to think about how to fix it. Okay, so let's be super clear on what we're talking about here. Algorithmic bias isn't just a one-off glitch or a random mistake. Nope. We're talking about systematic, repeatable errors that happen over and over again and create unfair results for certain groups of people, based on their race, gender, age, you name it.
Right, so where does this bias actually come from? I mean, it's not like engineers are sitting there intentionally coding sexism or racism into their programs, right? So how does it sneak in? Well, it's definitely not as simple as just one line of bad code. It usually boils down to three main ingredients, and they all kind of feed into each other. First, you've got bias data. Then you have the algorithm itself. And finally, you have us, the biased humans who build these things. Let me give you a perfect and pretty famous example of how this can go completely off the rails. So Amazon tried to build this amazing AI tool to screen job applications. Sounds great, right? Well, they found it was actually penalizing resumes that had the word women's in them, like Women's Chess Club. So why would it do that? It's because the AI was trained on a decade's worth of the company's own hiring data, which historically came from mostly men. The AI basically just learned to copy the company's past biases. It was such a mess they had to scrap the entire project. Okay, so if these systems can be so biased, what do we do about it? How do we fight back? We can't just cross our fingers and hope for the best. The answer is to get proactive with something called a fairness audit. It's all about hunting for that bias before it gets out into the real world and causes harm. And we can boil a basic audit down to three really crucial steps. Step 1, you check the data. Step 2, you test the model. And step 3, you monitor the impact. Check, test, monitor. Pretty straightforward. All right, let's dive into step 1, checking the data. Honestly, this is where things go wrong most of the time. If the data you feed an AI is skewed or unrepresentative, the AI is guaranteed to be biased. It's that classic saying, right? Garbage in, garbage out. And this chart shows you exactly what that looks like. Imagine your training data is, say, 78% from one majority group. Well, of course, the AI is going to get really, really good at making predictions for that group. But what about the others? It has way less to learn from. And that's exactly how you get higher error rates and unfair outcomes for minority groups. Okay, so once you've checked your data, it's time for step 2, testing the model. And this gets a bit more technical. It means using actual quantitative metrics, math, to measure what fair even means in the first place. And here's where things get really tricky. It turns out fairness isn't just one thing. Do you want demographic parity, where every group gets a positive result at the same rate? Or maybe equal opportunity, which is about making sure qualified people from all groups have the same shot? Or how about predictive parity, meaning the AI is just as accurate for everyone? And here's the kicker. These goals can actually contradict each other. You often can't have all of them at once. So you have to make a tough choice about which kind of fairness matters most for what you're trying to do. And that brings us to the final step, monitoring the impact. And this is so important because a model can look perfect in the lab, pass every single test,
and still cause massive problems once it's released into the wild. You've got to keep an eye on what's actually happening to real people. And here's a heartbreaking example of why this is so critical. Let's go back to that facial recognition data we started with. There have been multiple real-life cases of Black men being wrongfully arrested because a biased facial recognition system got it wrong. These systems had passed their lab tests, but their real-world impact was devastating. A total failure that the numbers in the lab just didn't predict.
Okay, so we've looked at the problem and we've talked about how to find it. Now for the most important part, the path forward. How do we actually fix these biases and start building AI that we can trust?
Well, there are a few main strategies people use. You've got pre-processing, which is all about fixing the data before training. There's in-processing, where you actually build fairness rules into the algorithm. Then there's post-processing, where you adjust the AI's answers after it gives them. And maybe most importantly, there's always the human in the loop, having a real person there to check the AI's work. But, and this is a big but, there's no silver bullet here. Every single one of these methods has pros and cons. Fixing the data up front is great because it works for any model, but you risk messing up the data. Building fairness right into the algorithm can give you a better balance, but wow, is it technically complicated. And adjusting the outputs is easy, but you might make your model less accurate overall. It's all about trade-offs. And that really brings us to the single most important point of all of this. Fighting AI bias is not a one-and-done kind of thing. You can't just fix it and walk away. The world changes, the data changes, and AI models can drift back into old biased habits. It requires constant, continuous monitoring. It's a marathon, not a sprint. So I want to leave you with one final question to chew on. When a biased algorithm denies someone a job, or a loan, or worse, helps put the wrong person in jail, who's accountable? Is it the developer who wrote the code? The company that used the system? The government? Figuring that out is one of the biggest challenges we've got as we build this AI-powered future.